So in the continuation with Cannizzaro reaction, let's consider another reaction which is intramolecular Cannizzaro reaction. So again, if we see this compound we know it is an aldehyde with absence of alpha hydrogen, which encourages the reaction to be in the direction of Cannizzaro reaction, including the concentrated base and higher temperature conditions. So we know we have hydroxide ion. When it gonna attack over here, when it's C and carbonyl compound, so it will gonna a nucleophilic addition reaction. So when it will attack over there, this bond gonna flip over backside. So if we look deep into the mechanism, here OH gonna attack and O minus is going to be there. So it is an RDS reaction. So when it is an RDS reaction, it must be a slow step. So yes, it is a slow step. So when this oxygen gonna backflip over here, when it is a slow step, and IH with tag of an ion with an ion, a negative charge on it, gonna remove from here. When it gonna remove from here, simultaneously is gonna attack on this carbon, and there is a backflipping of this oxygen. So oxygen gonna take it electron pair and will get a negative charge. So again here if we see this reaction, if we have like a 2, if we replace this by deuterium, if we have hydrogen and we have deuterium over here, if we call it as a kinetic isotope effect, then we know that CH bond is a weak bond, okay, weaker bond, and it is a stronger bond. So rate will be higher over there. So if we are asking isotope effect, oh yes, in case of CH it will be higher rate. So yes, it is taking participate. So it is also checked by isotope effect. Now O minus going here, then H negative will be here, H negative gonna attack here, and O minus will gonna backflip over here. So again there will be an intramolecular acid base reaction. So it will form this O minus will take this H plus. We know instead of solution it will take from intramolecular, because we know intramolecular reaction are faster than intermolecular reaction. So this O minus gonna take this H and this forming this compound. So we know that how we get the order of this reaction. Now if we talk about one more compound, if we talk about this compound, if we give it the condition the same, the condition we have given in the case of intramolecular Cannizzaro reaction, will it show the Cannizzaro reaction or not? So we know it won't show Cannizzaro reaction, but because when it gonna attack over there, this will backflip, and when there is generation of negative charge and there is generation of OH, when this oxygen gonna again backflip over here, so this phenyl line, it won't shift, okay, it won't shift. Why it won't shift? Because it is a resonance stabilized and there is a partial bond correct over here. So it won't be showing an intramolecular Cannizzaro reaction. So let's again talk about the rate of the reaction. The rate of the reaction, we know this is the RDS reaction, and this is, we name it as a intermediate one. So rate is directly proportional to the intermediate of this reaction. Now if we see again, if we talk about this step, we have already talked about the first step and second step. Again we know, if we consider this is a reversible step, because if we take the possibility when OH will backflip, that the O negative will backflip, there is a possibility that OH will come again, and this reaction will go in backward direction. So if we take that possibility and we give the rate, the equilibrium constant as K1, and we write here the concentration of intermediate divided by concentration of reactant, and what the reactant is over here, hydroxide ion and this aldehyde. So here we got the value of I, and by cross multiplying it, so if we put this value of I, so we get the rate expression of this reaction, which clearly tells it is a second order reaction. Here it is 1 and 1, so it is a second order reaction.